Hi, you guys. In today's lesson, we're going to be talking about two-way tables. Two-way tables are a tool that we can use to help us determine if there's any association or correlation between two different data sets, similar to how we've been using scatter plots for that same reason. Our first example here says a poll of 120 town residents found that 40% own a bike. Of those who own a bike, 75% shop at a farmer's market, and of those who do not own a bike, 25% shop at a farmer's market. And we have to fill in the information in the two-way table. So we're going to start in the bottom right cell over here, and we're going to enter the total number of people polled, which was 120. Next, we're going to fill in the right column. So 40% of 120 people polled owned a bike. So we need to do 40% of 120. Remember, to take the percent of a number, you're going to convert that percent to a decimal by moving the decimal 2 places back. So that would be 0.4. And you're going to multiply by the total amount, which is 120. And I'm going to get an answer of 48. So 48 people own a bike. Then the remaining people polled do not own a bike. So I'm going to take 120, subtract 48 from that, and I get 72. Then we're going to fill in the top row. So we started with the right column. Now we're going to do the top row. And remember that columns are vertical and rows are horizontal. So I'm looking now at the top row. Our instructions say 75% of those who own a bike also shop at the market. The remaining bike owners do not shop at the market. And this information is coming from the problem up here, right? So 75% of those who own a bike also shop at the market. So I'm going to do 75% as a decimal, which is going to be 0.75 times my total amount of bike owners, 48. And that's going to give me 36. So now I'm going to fill in that 36 of these bike owners also shop at the farmer's market. And if a total of 48 bike owners are there, then that means 12 of them do not shop at the farmer's market. Okay, now I'm going to look at this second row. 25% of those who do not own a bike shop at the market. So now I'm going to find 25% of the amount of people that do not own a bike. So I'm going to do 0.25 times 72. And that's going to get me 18. And if 18 of those people that do not own a bike shop at the farmer's market, then 72 take away 18 leaves me with 54 that do not shop at the farmer's market. Finally, I can fill in the last row by adding these columns together and finding the total number of people that shop at a farmer's market and total number of people that do not. So when I add those up, I get 54 here, and I get 66 here. Okay, so this is how we can complete a two-way table given some information. Down here, this definition goes over relative frequency. This is going to come up a lot in this section. Relative frequency is the ratio of the number of times an event occurs to the total number of events. So for example, the relative frequency of bike owners who shop at the farmer's market would be 36. Bike owners who shop at the farmer's market would be 36 out of 120. And that ratio is equal to 30%. We can use these relative frequencies to decide if there's an association between two variables or two events. On the inside, example 2 says 100 teens were polled about whether they are required to do chores and whether they have a curfew. We want to determine, is there an association? So now we're going to have to look at that relative frequency between having a curfew and having to do chores. So we're looking if there's a relationship there according to this data of people who were polled. So first, find the relative frequency. Okay, so I'm looking for a percentage. When I'm asked for that relative frequency, I'm looking for a percent of having to do chores. To do that, I'm going to find the total number of people who have to do chores. Okay, total number of people who have to do chores is 20. And I'm going to divide that by the total number of teens polled, which is 100. This is 0.2, which, turning that to a percent, I move that decimal the other way, and this would be 20%, not 2%, 20%, because you want to make sure that you're moving that decimal twice. Step 2, find the relative frequency of having to do chores among those who have a curfew. Because remember, we're comparing an association between having a curfew and having to do chores. So now we're looking at the number of people with a curfew who also have chores. The number of people with a curfew that have chores is 16. And I want to divide that by the total number of people that have a curfew, which is 32. This is equal to 0.5, which is 50%. So now we can make a statement about the association. Students who have a curfew are more likely to have to do chores than the general population. So there is an association between those two things. And we know that because of the relative frequencies. The relative frequencies show that students who have a curfew, right here, are more likely to do chores than the general population that's polled. Okay, so more likely. And that's because using my relative frequencies up here, 50% of people with a curfew who have chores, out of people that have a curfew, that's greater than 20% of people that have to do chores in general. All right, let's look at our final example here. Data from 200 flights were collected. The flights were categorized as domestic or international. That means in the United States or across the world. And late or not late. Is there an association between international flights and a flight being late? Okay, so now we're looking at if you're flying across seas, flying somewhere else in the world, not just in America, is there a relationship between that and your flight being late? So first I'm going to find the relative frequency of a flight being late. Okay, so to do that, I want to look at total amount of late flights, which is 40. And I want to divide that by my total number of flights. So this is giving me just a percentage of total late flights. And that's 20%. So 20% of all flights, whether they're domestic or international, are late. Now I'm going to look at the relative frequency of a flight being late among international flights specifically, because that's what I'm being asked about. So the number of international flights that are also late is 10. And this I want to look at out of the total number of international flights. So looking here, the total number of international flights is 50. And when I divide this, I also get 20%. So now when I compare, international flights are just as likely to be late than flights in general. There is no association. The relative frequencies show that international flights, once again, are just as likely to be late as any other flight. And that is because our relative frequencies are the same.